Good evening, everyone. Thanks for making it out here this evening. The weather's been rather ordinary, I know, but good on you for making it to the club. And for those that are on Zoom this evening, a hearty welcome as well. But this evening we do have Jack, who's kindly stuck his hand up. Tonight we have a presentation on Reflow ovens. Who would have thought that some of these ovens could actually be used for more useful purposes. I'd like to hand over to Jack and perhaps Damien, who are going to share their experiences with Reflow ovens.
Okay, well I think everyone knows me. I don't know about the everyone. Where's the camera over there? Everyone on YouTube or there we go. Yeah, so I thought all of the trials and tribulations I went through building this machine here, I thought it might be interesting, you guys might find it interesting that the process that I used, actually this one was going, I'll just make sure it's in cooling mode, so I just made sure it worked because I'm going to reflow something in it a bit later, so it'll be no good if it doesn't work. If it fails, I at least want to know beforehand. Okay, see if I can bring up the presentation. This particular one, I've tended to write more text about it, so we'll go through what I've written down here. With more and more SMD kits using 0805 components appearing on the scene, it seemed logical to investigate a simpler way to construct them. At the time, commercial/hobby reflow ovens were not common and industrial ovens were extremely expensive and out of the reach of the hobbyists. That's changed a little bit now. You can pick them up fairly cheaply. So at the time, the common options for constructing with surface mount were hand soldering, solder paste, kitchen electric hot plate. So solder paste on the item and put it on a hot plate, any sort of hot plate, and hopefully get enough heat up, or solder paste preheating on the hot plate and a bit of hot air over the top to reflow. I remember years ago, a long time ago, I was at Martin Communications. This is back in the mid-90s, and they had a manual pick and place machine, and the reflow was done with just hot air, and I couldn't get the damn thing to work. Ended up burning holes in the board, but the board went pretty brown actually from the heat that was on it. Must have been a bad batch of solder, I'm not sure. But ever since then I thought, oh, I don't know if I know about this SMD stuff. And they weren't small components. Mid-90s, I don't know what the size is, but they were big. They were big components. Solder paste and hot air. So let's go here. So yeah, so your options, as you can see, was hand soldering, which I've done a lot of that in the last couple of years before I got this thing sorted out. Hot plate, hot air. Hot air rework station is handy if you've got, if you do a little bit of work in the shack. I've got the soldering iron and the hot air on mine, and I probably use the hot air more than the soldering for doing heat shrink. It comes in very handy for doing heat shrink, saves going out to the garage to get the paint stripper to do the heat shrinking. And then a reflow oven. Those reflow ovens, I think I've seen them for about $250, $300 Australian sort of thing at the moment. But Damien's saying you've seen reports about them and they're not really good. Expensive to ship. I had to look at the shipping price of them. So yeah, so they're your options you got, and so basically we've got the reflow curve here. So you can see that you've got to go through a preheating stage, and then it goes into a soak phase. So it just sort of sits there every now and again. If you watch, if I turn the oven on later, you might be able to see the light coming on and off when it's doing different phases. And in this phase, it'll be on all the time here, and then it'll go on, off, building it up a little bit. And then it'll go into the reflow, everything will come on, it'll take it up and it'll hold it up the top there for about 15 seconds in the reflow, then it'll just go into the cooling phase. And when it goes into the cooling phase, I have seen some ovens where the door automatically opens up, like a toaster oven, the door will automatically open up and a fan will start and cool it down really quickly. The guys that are really keen on building that stuff, but I don't have any of that. I just open the door up when it's finished. So, what do we need to get it going? I think it must have been probably the mid-2000s I bought this oven when I was going to try and get it working. And I bought the oven, so I got the toaster oven. Getting the one with it'll get hot enough might be a bit of an issue. You need to get up to about, if you're going to do lead free, up to about 250 degrees Celsius. That's pretty high for 250, 260 for one of these. I usually cut off before that, but you can disable the thermostat in them and just let them run wild and use another controller to control it. But yeah, so you need a toaster oven, some form of timer controller, solid state relay to switch the AC to the oven on and off, and a better temperature sensor. The temperature sensor in the oven, you couldn't rely on that to do that reflow curve I showed you in the last slide. Oh dear. So my first effort was I bought one of these cheap temperature controllers. So you would set the maximum temperature, and then you set a timer for it, and it would come on and go off. Just wouldn't work. I even mounted it in a box with a solid state relay and all this stuff, and it was just a waste of money. Might have even bought a second one at one stage there. The toaster oven was $30. That was pretty cheap. I think at the moment you'd probably get one for about $30, brand new. The second one along there, that's from Peter, VK380Y. He said he paid about $15 for that, but he picked it up in Abbotsford or somewhere like that, outside the library, or I think he was telling me. It was a Facebook marketplace deal outside some library. So he felt like he was doing a bit of a drug deal, getting a toaster oven out in the public area. Yeah, so the timer was no good. That was a waste. So I put the whole thing to bed. That's it. I just left the oven in the corner, sat there for a couple of years, and then came along. I can hand these around. I'll start these going. Someone can start. As a lot of you know, my passion is ARDF, amateur radio direction finding, and pretty much all of our receivers are analogue receivers. Now, there was a few digital receivers that came out. They started to get more and more popular, and those two that are going around, the one with the big loop on it is 80 metres, and the one in the square box is 2 metres, and they're all microprocessor controlled. But the boards in them, and when I saw them, they're double-sided PCBs. They're 3-layer boards, so pretty complicated, pretty complex. And I remember talking with Brian, VK3YNG. I think some of you will know Brian. I said, Brian, can you give me some hints on SMD work? And he says, the biggest hint I can give you is to come around here. So I went round to Brian's place, and he set up one of his pick and place machines to put all the solder paste on all the pads. He programmed that up, and then he sat me down in the corner putting components on. Now, my eyesight's not great, and these are 0805, and I had a magnifier there, but and Brian kept looking over and he's saying, how you going, you ready yet, you ready yet? And there's probably about, on each side there'd be about 40 components to place on the board. And I remember doing the board, and I'd swipe my hand across and it'd move some of the components. Now the capacitors, those of you who've worked with Surface Mount, you know the capacitors don't have any values on them. Resistors are fine, but the capacitors are. In the end, I just ended up putting what I thought was everything on the board, and then Brian reflowed them in the oven, and they didn't work. So I didn't tell Brian that, but I ended up having to take off the resistors. There's probably 1 or 2 resistors were wrong. That was easy. I could swap those around, put them where they've got to be. But the capacitors, I had to take every capacitor off. There was 40 plus capacitors on each board, and I measured each one before I put it back on. Well, they were all hand soldered, those boards, by the way. But later on, when I got these working, the 80 metre one, the ARDF group decided to do a bulk purchase, and they bought about 24 of them, and Brian he set up a pick and place machine and loaded all the boards. They all come out beautiful and all tested, and everyone got their kit, and all they had to do is just basically make the case and get the loop on there and the buttons and all that sort of stuff, put the display in. So that made it a lot easier, but it got me interested again. And then Peter, VK380Y, who I mentioned before was the one in the middle there, he got interested in it and he kept asking me questions about the Reflow oven. And Peter said, oh, I found this controller board, because I said the controller board was the biggest problem I had. And he said, I found this controller board, it's out of Singapore, and it's called a Rocket Scream. And Rocket Scream tiny reflow controller. It's quite a small device, and you can see down the bottom here, it's got its solid state relay goes in here. Your power, 12 volts, goes in here to power it up. Oh no, sorry, that controls the power to the power to the relay, and the solid state relay goes in here. And then there's a USB up here to power the whole thing up. There's two buttons here. One button does start stop, and the other one does lead free and lead solder. And you can see it's got a little display. This is a little 1-inch screen type device, and it'll ramp up. You'll see the curve going up there. It'll give you a temperature readout as it's going up and what phase it's in. So it's quite a nice little thing. That was about, I think it was $35 plus shipping from Singapore. But the trouble is the guy doesn't make them anymore. He's discontinued that project. I'm talking about probably just before COVID. This was pretty popular. There's a couple of other choices. Damien, the oven on the far left there, that's actually a air fryer, and Damien's disabled most of the air fryer functions in it, and he just uses the on-off function because of the controller. His controller came from the Ukraine, and was it, Damien, about 70 Australian dollars plus? Yeah. So I got to building the controller. So the little controller here, the display goes in the front there. The controller board's there. 12 volt power supply to run all the 12 volt stuff. And there's a 5 volt supply over here. I found it easy just to get a USB supply and use that to run the Rocket Scream on 5 volts. And then you've got your solid state relay here. And that's controlled, or temperature's controlled by a thermocoupler going out there. I've got a fuse in there and a ceramic. For some reason I put a ceramic AC in there, and two buttons on the front to do the two function and an on-off switch. So it was a pretty easy build. For me it was easy. The oven modifications I had to do were really not that much at all. All I needed to do was, I'll hand one round actually. If you're thinking about building one of these thermocouplers, a lot of you guys that have bought multimeters will recognise that. It comes with a thermocoupler on a lot of them. They're not real good. Peter's got one in his, he seems to work okay, but the trouble I was having with them is I didn't want to mount it through the side of the cabinet. I couldn't work out how to hold it properly in the side of the cabinet and get it working properly. So I just used to put in the door, shut the door, and it worked fine for a few jobs. And then it started to, the Rocket Screen could say error. Every time I shut the door, it would go error, error. Now it was either capacitively coupling with the metal in the cabinet, or something was going on. So I decided, looked around, and I thought I'm going to get one that's got a nut and a bolt on it, and I can drill a hole through the cabinet and mount it. And you can see over here it's mounted in the side of the cabinet. These come in lengths of 100, 150 or 200 sort of thing long. Stainless steel. But I still had the same problem with it shorting out in the cabinet. So I needed to insulate it from the cabinet. And because it's getting into temperatures up around 250 degrees Celsius, I needed a decent insulator where it goes into the cabinet. And I ordered some Bakelite ones off eBay, but they were only, they were 16 mil, so they had like a, I think it's 8 mil, the hole in the middle, 8 mil and 16, so it didn't really give you much room to make a bigger hole so you could slide it round and it wouldn't connect. So looking around, I went to electrical wholesale, thinking they might have something like that, some insulated washers, and he says, no mate, not here. Go around the corner to Quaidor. Now Quaidor, some of you guys would have been to Quaidor in Mitcham, in Queen Street, Mitcham. They're manufacturers or manufacturing, and they sell big switchboard equipment, cabinets, all the gear that goes into switchboards. So the guy said, oh, you need some of this stuff, and he gave me this, it's like fiberglass, just gave me a sheet of this stuff here, and I just cut out washers out of it. Just got the hole saw and cut it out, then drilled the 8 mil hole through the middle, opened the hole up to 8 mil, and they work perfect, absolutely perfect. I'm not sure what temperature they'll go up to, but they work really well. And then inside the oven, I just cable tied a few things down. But what I did do with my oven is I covered the metal braid up with that's high temperature. Where is it now? You probably can't see, but that sort of rubberized, it protects the cables against heat. So I wrapped it, or I slid that over that. Now Damien's got a story about that, which his braid got out, but his braid got out and shorted out on some AC, so he blew the RCD on his, and he was ringing me up and asked me, what's the what values you're getting out of your sensor? And I had the multimeter out, and I'm giving him to him because they're just different value each time. If my house is 20 degrees and his is 23, it's different. But he says, oh, I think it's okay. I think it survived. Yeah, so mine was shielded all the way, or shielded or was covered all the way. So looking at the ovens, this one on the left-hand side, that's my oven with the black Boxer controller on there, and on the front you can see you've got your 2 buttons there for your start, stop, and your lead-free and lead solder on-off button, and the display there. The reason it's white and not black is because when I was printing out these screens, trying to get the right screen for the 3D printer was a damn nuisance, like the right bezel. In the end that one worked, and I just chucked it in there. The Reflow oven I don't use a lot, so it sits in the corner, so it didn't matter. I didn't have to look at it all the time. Whereas Damien, it'd be a different story. With Damien, if he was doing it, it'd be a totally different story. That'd have to be black, and it'd have to have a really neat fit and nice and square. But I'm a bit rougher than he is, a lot rougher than he is. Now Peter 380Y, he decided to put his into a box with a clear lid, and he's got the little display screw to the top. When you get to the ovens, his oven is just using one of those cheap thermocouplers that I just handed around, and it seems to work okay for him. Now he's got around the edges of the door, mine's got this foam, furry stuff around the edges of the door. I was looking around for some heat resistant material that when you shut the door would keep the hot air in rather than let it out. And I came across this roll of stuff that was for pizza ovens. And I got a roll of it and put it on, and it doesn't worry all about the heat. It's really good. Now Peter's gone a little bit further, and he's put high temperature tape all over the glass, except for a little window that he can look in and see what's going on inside. That'll certainly keep the heat in on that one. I haven't found it being a problem because I've never done lead free. I've only done lead solder. So if I did lead free, I'd probably need to retain the heat a bit better, and I might have to go that route. But he found a guy down, I think it was in Morak Road in Vermont, somewhere like that. Some guy was selling it, so he got that from there. Yeah, so and then we get to Damien's. I'll have to come across over here to Damien's oven. As I mentioned before, Damien's controller came out of the Ukraine. and he happened to find a 3D printed case that suited the controller. So he got me to print that out, and he's mounted it all nicely on the top there, and he even got a strip of that insulated stuff I've used for the washers, and he got a strip of that and put it underneath here to try and protect a little bit. Actually, I've got a couple of things here I can show you. Oh, this is Damien's controller. I only just got a 3D printer when I was printing these out, and I thought it was fantastic the way they, oh, the button's fallen inside somewhere. I probably should have put some tape around it. I'll leave it in the bag. But I'll just hand it round, I think. But the buttons all print out when you do the 3D print. The holes are left in the case, the buttons are there, and you just push the buttons in and they match up with the buttons on the board. So just be careful of that, the back will fall off. If the buttons get lost, I'll have to print some more. But yeah, so Damien's is, as I mentioned before, he's just disabled a lot of the stuff for the toaster oven. He just uses it. Actually, you use it for drying paint, don't you? Probably more so, rather than the missus oven in the kitchen baking paint. It's nice to have it out in the shack to bake the paint. There's pretty much not much else I can say other than giving you a demonstration. The other thing, I've got a few things here. I bought the soldering station here. I've got a board there. A couple of boards I'm going to put in there, and the ICs will just run a strip of paste down each side, so they'll end up with shorts all the way along. But a bit of solder braid usually cleans those off. But if you've not tried SMD before, doing SMD stuff, it's not really. I like it actually, as long as I've got a nice magnifier I can look into. It's really good. But some of the tools that you might want to look at is decent pair of tweezers. And I'm talking, if you look at these, you'll notice they're different. These are SMD tweezers. They've got a little boot on the end of them. They sell them at Ultronics. A little resistance and capacitance reader, which I find handy, and a soldering iron with two jaws on it. That comes in very handy for lifting stuff off. Otherwise, you've got to use two soldering irons to come in to lift the component off. Or I've got Damien's got one of these little preheating stations, and you put the board on the top here, turn it on, hot air comes up, and it just warms the board up, and then you can come in with hot air gun and just solder it. So that's basically doing the preheating, then you're coming in with a nice gentle heat and it'll reflow, the reflow. That's good if you're doing rework stuff as well. Excellent for rework, because you can warm up the board, then you just come in. I know when I've done rework with the thing, you turn on the heat and it's not going yet, turn it up harder, then components start blowing all over the place. So this is much nicer. Yeah, so I don't know, let's do a reflow. We'll take this stuff off the top here, because this is the oven we're going to use. Damien's got a sad story about leaving an oven on with some plastic on top of it. Doesn't like it. Ended up melting. So what I'll do, I've got two boards here, and hopefully I can put them in there and they show the board before and after. Okay. I'll take that off. I prepared these this afternoon, so hopefully they. So the most critical components are the two ICs on there. The others, hopefully, they'll reflow nicely. I'll just put them in here, and see what happens. I wish I had this when I was building those receiver boards though. Would have made it a lot easier. Okay. So basically, we'll turn the controller on. You won't be able to see it from where you guys are. Can I reach over there? I don't think I can actually. It's telling me it's ready and it's on lead solder. So I'll just hit the start button, and if you can see if the lights weren't so bright, you'll see that light will come on. The oven light will come on. And if you can I don't know if can you zoom right in on that little controller? No, you can't see it really. It's too. Yeah, I don't think I can get it over to that device over there easily. It won't reach over there. But one good thing about getting that that temperature sensor, the thermocoupler in there over the top, was that it's right where it needs to be, right where it not where you poke in the poke this one in the side of the oven. And well, Peter's got it clipped in there. But as I said, every time I shut the door, it would go error. Every time I shut the door like that, it's error. Now there's nothing metal in there or anything like that, but it was just giving me an error, so it needed to be insulated. It's back. It'll take a while to go through that process. I'll have a look there now. Yeah, it's only up to 40 degrees, 50 degrees at the moment.
So is this the standard curve, Jack, or can you adjust the time?
No, that's all programmed into the controller.
You can on the one, the blue one. So if you had a bigger board, it might take longer to heat up, for instance.
Would if it was, yeah. I probably would heat quicker if I put some stuff on the glass as well, like Peter's done here. Retain the heat, some reflective material. But it's still in the preheat mode. It's about 80 degrees. But it really starts cooking. You'll see everything come on. The top and bottom heaters will come on, but you can't really see it with all these bright lights here. And then it'll go into the soak mode shortly. I might just bring up that slide that's got that screen on it so you can look at that. There's not much you can see with that oven. So I'll just have a look there and see what mode it's in at the moment. It's in the soak mode. That's why it's crawling up that line where the soak line is. It's just sort of going a little bit hotter, a little bit hotter, a little bit hotter, a little bit hotter, on and off, on, off, on, off, on, off sort of thing. And then any second it'll go into the reflow mode. It's basically, it's about 100 and, what was it, 120? No, one's, oh, I don't know. I can't see it. I must have mucked up this. No, I think it's about 190. But it'll be about to go in the reflow mode. I think, there we go, reflow now. It's just gone into reflow, so everything will come on. It'll get hot as hell. And I don't think I can, oh, I can see stuff happening in there now. There it goes. I can see some of the components going shiny. So it's starting to do the reflow. Leave it doing that until it gets into the cool mode, and I'll open the door up, and then when it cools down a bit, I'll be able to take one of the boards out and put it under the camera. So it's still in the reflow mode. There is one component in there that's quite heavy, and that's an inductor. Yeah, I think I might have mucked up this screen when I was mucking around with it too much. I haven't used it since I put it into this box here, and it's got a few dots on the display, so I think I'll probably sitting on about 210 at the moment, and any second it should go into cool, hopefully. It's certainly soldered, that's for sure. I can see it's all shiny. There we go, it's finished. There's a on the little controller there's a fan one, so it'll switch to the fan. Damien said he can't get the fan to work on his. That's also got a little fan output on it as well, and this has got a fan in it. What can I use to get that out? Get those tweezers. But those tweezers are great, but I think they're about $16 a pair. They're pretty exy, but at Ultronics. See if I can get this out without. Okay. How close does this get? Oh, pull. Pull. You can get a better idea. You can come up and have a look anyway when it's all cooled down. But hopefully it's all good for you, Damien. What's that off? Is that the rotator controller?
Yeah, that's A to D board.
Okay. All right, and I'll take the other one out as well while I'm at it. Yeah, so that's about all I've got. But anyone got any questions?
Do you use flux?
No, not really. I've just cleaned the board with some isopropyl alcohol and just put straight solder paste. The solder paste.
It's got the flux in the paste.
Yeah, there is flux in the paste. One thing that if you do buy solder paste, and it normally comes, the hobby stuff comes in a tube like that. You can buy it in a tin, so it's like a syringe. And but keep it in the fridge. Even when you've opened it, keep it in the fridge. It'll last forever in the fridge. Keep it chilled. You can leave it out for a while. This will go back in the fridge when I get home. But this one, one thing that happens with them is that it's quite common. This breaks off. The plunger breaks off. You can still use it. That's like got half a tube of paste left in it. But I bought another one to in case this one run out, and I've got here in. Yeah, but I must have gone through another tube of that one. That's it, Ultronics. Yeah, they sell it down there. I'm sure they sell it. J-Car sell it as well. Yeah. Yeah. Same sort of deal in a tube like that. Yeah. And yeah, so that's where you get that from. But you can use flux if you wanted to, but I've never had to bother with it. Just clean the board off, isopropyl alcohol, and away it goes. It seems to work fine. What else does I mention? No, nothing else. Oh, one other controller here. This one's an Australian controller, but it was how much US?
I looked it up. It's
89 US dollars. All right. Okay, that's it. No more questions on Zoom or any here? No, good. All right, thanks for that.
Okay. Thanks very much, Jack. Well done. And,
Yeah, okay.
Damien, for your admirable support. Very interesting, and I'm sure it's given a number of our members something to think about over the coming weeks. Perhaps we'll see more developments.
Fair enough.
But thank you, and everyone, tea and coffee. Come up, have a look, and no doubt there'll be further questions that you'll have for Jack and Damien over the next little while. Thank you one and all for coming.
If you'd like,